Yoo-hoo! Welcome to Unit 4, Electrons. So a while ago, you learned that came up with the planetary model. So we're like, hey, electrons live here. Okay, but it's actually not that simple. So later on, Bohr and like Heisenberg and Schrodinger, they discovered something called electron orbitals. Okay, electron orbitals are where electrons are found. So electrons are found there. Each orbital holds 2 electrons. So they're like these three-dimensional areas where electrons are found. And so in each one of those areas, 2 electrons can fit inside them. There are 4 different shapes of orbitals. So let's go through each one really quick. The first one is called the s orbital. You can think of it as a sphere shape. Okay, there's a picture off to the side, but I'm just going to draw like a small little ghetto sphere there. So you can think of this as like a particular house. So in this S orbital or in this S house, there's like, in this really, really tiny house, there's one bedroom. Okay, so there's only one bedroom inside this one tiny house. And so each bedroom, each orbital can fit 2 electrons. So it's really small, really tiny. We say that it is low energy. So you can think of it as like a really cheap house. You know, it's really small, only 2 people can fit in there, really, really cheap, okay? The next one is called the p orbital. So you can think of this as a peanut shape, where it sort of looks like this infinity symbol, like that. So p orbital or p house is a slightly bigger house. You can think of it as a 3-bedroom house, okay? So it has 3 bedrooms that can fit 2 electrons each. So how many electrons can fit in there? So 3 times 2 is 6, right? So you can fit a total of 6 electrons inside a p orbital, p house, because it has 3 like orbitals in there. We say that the energy is medium. So you can think of this as like a slightly more expensive house, bigger, more bedrooms, right? More orbitals means it's slightly more energy, more expensive. The next one is the d orbital. You can think of this as like a simple daisy. It has like 4 petals, 1, 2, 3, 4, like this. This one is a pretty big house. So big orbital, it has 5 bedrooms, okay? So think about if you can fit 2 electrons in each bedroom, then you can have a total of 10 electrons that live inside this d orbital d house, okay? We say that the energy is very high, okay? So think of this as a pretty expensive house because more electrons can live in there. The last one is the f orbital. We're not going to spend too much time learning about the f orbital, but it's really crazy looking. So I like to just say it's like a really crazy flower. It has lots and lots of petals, and it's really hard to describe. You can look at the picture over there, but it has a lot of petals, a lot of things going on. This is a really big orbital, really big house. It's a 7-bedroom house. It's like a mansion, right? So if 2 electrons can fit in each bedroom, right? So 7 times 2 is 14. So you can fit 14 electrons in there. That's a really big house. It is a very high energy area. So you got to think it is like super expensive, lots of energy. So that's the kind of way you want to think about it, okay? So electrons don't live on these like rings. It's not as simple as that. We like to draw that because it's like 2-dimensional, but through the 3-dimensional world, they actually live in a 3-dimensional area called orbitals. So in order to draw them visually, it's hard to draw them draw 3-dimensionally for everyday people. So we came up with this thing called orbital notation. So orbital notation is a way to explain where electrons are, where do they live, but not draw them 3-dimensionally, but show them where they live in these orbitals. There are 3 rules of how to show orbital notation of how electrons fill inside these houses. I'm going to talk about them really quick, and then I'm just going to show you an example. First one is Aufbau principle. The key word here is that you start at the lowest energy. So basically think of this as like the cheapest house, okay? So Aufbau is German for filling up. So you always start from the lowest energy and you work your way up. So like the cheapest house going to the most expensive house, okay? So the Pauli exclusion principle, that's rule number 2, says that you can fit 2 electrons inside each bedroom of a house, right? So the key words here is 2 electrons of opposite spin. So when we draw it, we're going to draw an up arrow to represent 1 electron and a down arrow to represent another electron. Okay, so opposite spins. They always have to be pointing in opposite directions. Number 3 is called the Hund's rule. Hund's rule is each electron wants to be in its own bedroom, right? Before you double up, before you give it a roommate, everyone prefers to have their own room, right? So that's Hund's rule. Now, it's sort of complicated. So I'm going to show you an example first, and we're going to sort of work backwards. So I'm going to show you this example using our 3 rules, and then show you how we can use our periodic table after that. So here's a visual of low to high energy, low energy orbitals that we can fill up to high energy orbitals. So here it is an example, oxygen. So oxygen, according to the periodic table, has, right here, here's oxygen, it has 8 electrons, okay? So 8 protons, 8 electrons, we're assuming everything is neutral, okay? So if we go here, I'm gonna say that we have 8 electrons here. Now, earlier I said, for every electron, we have to draw an arrow. So we have to draw 8 arrows to represent 8 electrons, okay? So you always start with rule number 1, which is Aufbau's rule. Aufbau's rule says you start at the lowest energy, the cheapest house, okay? So what is the cheapest house? The cheapest house is right here. So this is really low energy, 1s. So level 1, you can think of it as like the street. Street 1 has the cheapest house, 1s. That's where the cheapest house is. In each bedroom, right, S house only has 1 bedroom, so you have this 1 line right here. Can only fit 2 electrons. So the first electron is going to be filled here, okay, and the second electron is going to be filled here, okay? So 1 up arrow, 1 down arrow. That's the Pauli exclusion principle, right? Has to be opposite spins, so you draw them opposite. Now this house is full, so no electron, you can't put a third one in here, okay, it's full. So you have to go to the next available house, next available orbital. So what is that? If you look here, so you gotta keep going, you go up, and 2s is our next available house, next available orbital. It's still an S house, so we only have 1 bedroom. Each bedroom, we can fit how many? 2 electrons, right? So I'm gonna put electron number 3 here and electron number 4 here, right? So if I were to like label these electrons, I drew electron 1 here, electron 2 here, electron 3 here, and electron 4 there, right? So I need to draw a total of 8. So I need to draw 4 more. Okay, so electron 5 cannot live in the 2s orbital. It can't fit in there. We're full, so we're at capacity. So we got to go to the next available orbital, next available house. So what is the next available house? If you look at the next level up right here, right, it's 2p, right? Remember the thing about 2p. So if we're going all the way back to the beginning here, the p's have 3 bedrooms. It's a 3-bedroom house, and it's a slightly bigger house, right? So if you look at this picture here, it has 1, 2, 3 bedrooms, okay? So the 2p house, so the entire house here, right, has 3 bedrooms. That's the entire orbital, okay? So that means we can fit our electrons in here. So electron 5 would go here, okay? So electron 5 is here. Now, comes rule number 3, which is Hund's rule. Hund's rule says you need to put an electron in each orbital before you double up. What does that mean? It means you need an electron in each bedroom before you double up. Like every electron wants to be by themselves, right? So they want their own room. So where would electron 6 go? Electron 6 has to go in the next available bedroom there, next available orbital. So we always draw up, up, up before we go down, down, down. So electron 6 is here, right? So electron 6 is there. Then where does electron 7 go? Electron 7, is it going to go here? No, because it wants to be in a bedroom all by itself, right? So where is it going to go? It's going to go in the next available one, which is over here, right? So that is where electron 7 is, okay? But we need 8 electrons to represent oxygen, right? So we have to have number 8. So the question is, where does number 8 go? So number 8 is in, a lot of people draw it in the wrong spot initially. So I'm sure you're thinking, oh, does it go over here? Does it go to the next house? No, because we have to fill all the houses, okay? We have to follow Aufbau's rule. You have to fill the entire house before you move on to the next house, okay? Like 3s is too expensive, so you have to fill in all of 2p first. So electron 8 is gonna go right here. So this is where electron 8 will go. Electron number 8 is gonna go back to the first bedroom, the first orbital, and now it's gonna have a roommate, okay? So 6 and 7 don't have roommates, but if we have to add more electrons, then they're gonna get roommates as well. So that's how we visually show how, where electrons are, where do they live in electron orbitals. So this is our visualization. Instead of drawing it 3-dimensionally, we use lines and arrows. This takes up a lot of space. So instead of drawing them like upwards, we draw them or we write them sideways. Okay, so I'm gonna write it sideways real quick down here. So we say 1s, we put the orbital on top of the label and we draw our arrows here. Then it would be 2s, and then 2p has 3 orbitals or 3 bedrooms, and I go up, up, up before I go down. So you see how this is like the smaller way, it takes up less space than what I drew before. So now you're wondering, okay, I can do this if this is given to me, but what if it's not given to you? How do you know where the electrons live? Well, that's when the periodic table comes in. The periodic table is a great way to show you where all the electrons live, okay? So I am going to label this, and I recommend that you label it on your periodic table as well, so you have it handy, okay? So where are the s, p, d, and f? So electrons live in specific homes, and they're pretty easy to label. So let's start with the s orbitals first. The s orbitals, s electrons is this area right here, okay? So I'm gonna label this S, okay, for the S area. Oh, I think that one's like a little, there you go, S. The p orbitals are over here. Okay, these electrons occupy p, okay? Then where are the d orbitals? The d orbitals are right in the middle here. So I'm gonna color this, label this, the d orbitals. And like I said, the f orbitals are not talked about too much, but you do need to know that they are here. Okay, so we at least can label them like that. So S, P, D, F, you should label them as well, okay? The next thing is that here is your lowest energy level. So you want to label that, right? So now we're gonna use this periodic table to tell us where electrons live. So remember, you always gotta follow your 3 rules. So we're starting with Aufbau's rule. Aufbau's rule says you always start at the lowest energy level. So where is the lowest energy level? Well, ask yourself, where is the first electron? The first electron is here, right? That's where hydrogen is. So the first electron lives right there. So let's look at it. It lives on what street? What energy level does it live on? It lives on energy level number 1. So when you draw this out, okay, then you can simply label it, right? Street 1, right? Then you look at the periodic table, okay, which area, what color does electron 1 live in? It lives in my green area, which is the s orbital. So then this would be the 1s orbital. You know that s houses are really small, okay? An s orbital, s house, it only has 1 bedroom, right? So I can put 1 electron in here. My 1 electron then is hydrogen. If I wanted to add another electron, that would be helium, right? So if I go back to here, where would I put the second electron? The second electron would be downwards like this. So I fill up my little s house, okay? So you look, helium is still in my green zone. It lives inside a s house. So far, we're so good, okay? So now let's look at electron number 3. Electron number 3, where does it live? So let's look at the periodic table. What street, okay, what energy level does it live on? It lives on street or energy level 2. So you would write here, hey, it lives on level 2, street 2, okay? What's the next available house to us? So electron 3 lives in which section? It lives in the S section. So it lives in an S house on the 2nd street. It lives in an S orbital on the 2nd energy level. So I write 2s. Remember that S is really small. It's a single 1-bedroom house. So if we put 1 electron here, that is lithium. Then where is electron number 4? Electron number 4 also lives in street 2, energy level 2, and in that S house. So it lives with lithium, right? Electron 3 and 4 are roommates. So how would you draw that? 1 up arrow and 1 down arrow. So if I were to label these with numbers, you won't see them labeled with numbers. But if I were to label them with numbers, this would be electron 1, electron 2, electron 3, and electron 4. So let me just do a few more examples, and then I'll show you like a good ways down the periodic table. So let's do electrons 5 through 6, or 5, 6, 7, 8, 9, 10 actually, okay? Look at electron number 5. So you always have to go in numerical order here. So after 4 is 5. Look where electron number 5 lives. Okay, so if the energy levels are really too far for you, you can like relabel them on the other side. So you can put like 1, 2, these are your streets, right? Your energy levels 4, 5, 6, like this. So where does electron 5 live? Electron 5 still lives on street 2, energy level 2. But what kind of house, what kind of orbital does it live in? It lives in a bigger house. It lives in a p house, right? So you would say that, hey, it lives on street 2, energy level 2, but it lives in a p orbital, p house. Now remember, back into your notes, how many bedrooms, how many orbitals does a p orbital have, right? So if you look back, okay, p orbitals, right, have 3 bedrooms, 3 orbitals, right? So if we go here, we need to draw that this p house has 3 bedrooms like this, okay? So you go ahead and pre-draw it. Then you look at electron 5. Electron 5 does live in a 2p house, so I'm going to draw that electron 5 lives here, okay? You can have empty bedrooms in the house, that's okay. But if I were to draw the next electron, where would electron 6 go? So remember, you have to follow the Hund's rule. Everybody needs its own bedroom before you double up. Everyone needs its own orbital before you double up. So electron 6 would go here. Then electron 7 would go here. Okay, then where does electron 8 go? So we're going back to our oxygen example, right? Electron 8 would then fill that first bedroom. You have to give it a roommate now, okay? It's not gonna go to the 3s house. It's not gonna go to the next house because it's too expensive. So it's gonna fill up all the bedrooms, right? So electron 8 goes there. Then where does 9 go? 9 goes here. And then 10 would go here, right? Same logic applies. So if we were to keep going, right? So we filled in 5, 6, 7, 8, 9, 10. Same logic applies to 11 and 12. Where does 11 and 12 live? Well, let's look. It lives on street 3, energy level 3, in the tiny S house. So on the next level, next street over, there is a tiny S house called 3S, okay? Then let's look. Where does 13, 14, 15, 16, 17, and 18 live? Well, they're still on street 3, right? So you gotta go across in numerical order here. They're still on street 3, but what type of orbital house do they live in, right? It's the P house, it's a bigger house. So I'm gonna draw it on the next page really quick, and then I'll show you a very special example about the d orbitals, okay? So give me just a second. Okay, so I went ahead and drew out the 3s, 3p, and I also drew 4s, okay? So 4s is electrons 19 and 20. So they live on street 4, 4s, and 19 and 20 are roommates together in that tiny S house. So I wrote 19 and 20 right here, where the 4s is. Now, it's really tricky when we get to electron 21, okay? So I'm gonna show you this quick example. So electron 21 live in a D house. Now you would think, hey, it looks like it's on energy level 4, like street 4, but it's not. These are really, really special. And because they are special, they actually live on a different street. So you actually have to write 3, 4, 5, 6, like this. So you're probably asking, okay, why does electron 21 live in street or energy level 3? Like, why does it all of a sudden go backwards? Well, it's a little bit complicated, but the 3D house is more expensive, right? More expensive than the 4S house, okay? But it's cheaper than the 4P house. So it's like really like sort of in the middle. So like, the d orbitals, right? D orbitals are such a big house. They have a really high energy. It's really expensive. So 19 and 20, electron 19 and 20 sort of hop to the next street over. They fill up the tiny, less expensive S house first. But then 21 and 22 are like, okay, I have to go to the next available house. So they're gonna go back to street or energy level 3. And finally fill up that really big expensive house back on street 3. So they're gonna go back 1 and fill up that big D house, okay? So now if you recall, the D orbitals, okay, they have 5 bedrooms. It's huge, right? And so because it's big, like I said, it's more expensive than the S house, right? But it's cheaper than the next P house. So that's why they have to go 1 street back to street 3. Street 3 is supposed to be cheaper than street 4. Okay, so then if you write this out, it would be 3D, right? It has a 5-bedroom house, 1, 2, 3, 4, 5, right? Hund's rule still applies. So if you're trying to draw electron 21, you would draw it here. Electron 22 would go here. Next, you have to follow Hund's rule. Everyone wants their own bedroom. So you fill up each bedroom, right, before you double up. So electron 21 is here, 22, 23, 24, and 25, right? Then you go back and fill up, give everyone a roommate, right? So then it would be 26, 27, 28, 29, 30, right? So this would be electron 26, 27, 28, 29, 30. You're never gonna see any of the examples with actual numbers on them. I'm just writing the numbers just for your note-taking purposes, okay? So last example that I'm gonna do. After you fill in 21 through 30, then you're back to 31, right? Electron 31 lives where, okay? Remember, you got to go back to the P house. So now we're back on street 4. We're back at street 4 because 3P was already filled up, right? We filled it up with electrons 13 through 18. So street 4, we have to go back to street 4, energy level 4, and we have to fill it in the houses there. So 31, 32, 33, 34, 35, 36 all live in the 4P house. So it's a more expensive house. So these electrons are filled by cheapest to most expensive. So like low to high energy. So if I were to draw the last 6 really quick as an example, after 3D, we have to go back to 4P. That's the next available orbital, next available house. Remember, P's have 3 bedrooms, 3 orbitals. So you fill in going up, 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 before you go down, down, down. So if I were to label them really quick, this would be electron 31, 32, 33. This would be 34, 35, and 36. So if you look at electron 36, that's krypton, and it fills up like that. So you just keep going and going and going and going. And eventually you'll get to the F's, the F orbitals, but they're sort of complicated, so we're just gonna skip those for now. Just giving you some examples on how to do at least the orbital notation and at least recognize them, okay? Awesome. Okay, so now we are going to shorten our orbital notation into electron configuration. So electron configuration is like a shorthand way of writing orbital notation. So we're gonna stop writing lines, stop drawing arrows, and we're gonna use superscripts instead to represent how many electrons live in that orbital or live in that house. So for example, you know, we still have to follow Aufbau's rule, right? So we still have to fill in the lowest, the cheapest house, which is 1s. But how many electrons live in 1s, right? So in the 1s house, we have 2 electrons that live there total, okay? Then you go to the next level. The 2s house can fit a total of 2 electrons. So that's where this number comes into play. Then after that, right, you have the 2P house. But the 2P house, remember, it's a bigger house. It has 3 bedrooms, 3 orbitals. So you got to count all the whole thing, the entire house. How many electrons live in the entire house instead of each bedroom? So this whole thing, there are 3 electrons that live in that house. So if you count up the superscripts, right, 2 plus 2 plus 3 is 7 electrons. So it is nitrogen. So following the same example down below for oxygen, right? So here in the 1s house, you have 2 electrons. So that's where this 2 comes from. After that, you have the 2s orbital, the 2s house. And so that is 2 right here. And then after that, you have your 2p house. So you got to count the entire orbital. The entire house has how many arrows, how many electrons? 1, 2, 3, 4. That's where this 4 comes from. So 2 plus 2 plus 4 gets you to 8, and that's how you know it's oxygen. So it's a really short way of writing. You just count 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, and put that number as a superscript instead of drawing out all the arrows. Okay, hopefully we'll do more practice in class.